Okay, so in the first episode, we learned how to get so far as converting um, a particular letter to ASCII in binary, but we're stuck with this unwanted group of characters as opposed to having those as individual numbers. So the first thing we're going to do is the string split command. Um, And you see that the string split, when we said that we could split it anywhere we want, but if we do null, that'll just do after each character. That gives us ones and zeros. So we're already getting a lot closer. You'll notice that for some reason it's returning a list. Whenever you have the double square brackets, that means that it's a list of items, and we don't. It's odd that they do it this way because there's only one thing in the list, but in any case, we want to do it like this. Now you notice but the square brackets have now gone away, and that's good. That means we're getting closer still. And then finally, as numeric is going to take us all the way home. That gets rid of the quotation marks. As dot is a very standard notation in R. Later, we're going to talk about as.matrix. There's also things like as.dataframe. So if you have data in one format and you need it to be in another, trying to find a command that starts with as dot is usually a good way to go. Okay. We could, of course, store the letter H that way. So just say we wanted to get back to decimal. That's actually really easy, a little more intuitive. This gives us the numbers 6 down to 0. And if we go like this, you'll notice that that gives us all of the powers of 2 that correspond to that sequence. And of course, by doing 6 down to 0 as opposed to the other way around, this puts the larger numbers on the left-hand side, which is exactly what we want for when we're converting back to binary. This is the command for matrix multiplication, and we do that, and it goes back to 72. Now, we just wrote our little ASCII function, and voila, it is the same number. Okay, notice, oh, this is just a little note. We're going to fix this inside the function in a moment, but the integer codes the binary codes for the digits is smaller, and it only takes up 6 digits, and so we don't want to get mixed up about where our letters start and stop. So we're gonna fix that. I wrote this function called letteRToNumber. It works for either binary or decimal. I'm going to show a little bit how it works, and then I'll come back and explain how it was written. So letteRToNumber, if you set this option binary to false, it gives you, of course, a number. If you set it to true, then it gives you back the number in binary. And just to make sure that it works for digits, yes, it has correctly given us a lead 0. Okay, so what's going on in this function here? Well, it's our function takes 2 pieces of data, the letter that we want to convert, and then this Boolean, a true or false value, for what kind of number we want back. And then I just have this little if-else statement. So if we're in binary mode, we're going to do just that exact command that we talked about above, and we're going to follow that up by double checking if the number of bits is less than 7. And if it is less than 7, we are going to use the combine function. The C stands for combine, and so that's how we combine the 0 on the front there. Okay. And then, of course, return is the command that we use to specify which piece of information should go back from the function, either to the console or to the variable where we're storing it. So now we can do this to write out, words as long as we like. So that is hello, written out in binary. This, by the way, is an example that Simon Singh works through in Chapter 6 when he's talking about binary encryption. We use David as our key, our pass key there. And what we're going to do to encrypt the text, and this is what's different about contemporary or binary encryption, is that you actually do the encryption on the individual ones and zeros as opposed to on particular letters. It makes it a bit sneakier. So all we're going to do is add our plain text, in this case hello, to our key, and then we're going to take mod 2. The reason we take mod 2 is because if we were to add 1 and 1, we would get the number 2 And of course, that's not a number in binary. So to stay in binary, we have to do a little clock arithmetic and take mod 2. And actually, we can go back the same way. And let's say that we didn't want to look at all of those 35 ones and zeros. We could confirm that the ciphertext that's been decrypted is the same as our original plain text by running this command. Okay. Well, that's the end of this one. Oh, one very little note before I go. You'll notice that I don't move the mouse very much. It's often faster to use the shift command, hit shift to highlight things. But then if you hit command enter or control enter on a PC, that'll run whatever you've got highlighted. So I find that very convenient. Okay, till next time.